All right, so now we have angle, angle, side. Okay, angle, angle, side is similar to angle, side, angle, except this time there's nothing that connects the two angles together. Okay, so we don't have anything that connects the two angles together. Up here, this right here is what the criteria that you're going to use to prove triangles are congruent using angle, angle, side. Okay, so in this case, you have two angles and a non-included side, so a side that does not connect the two angles together. Okay, so if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another, then the two triangles are congruent. So they're saying non-included means a side that's opposite of the angles. Now, what's tricky about this one is identifying whether or not the side that is not included is going to be the same on both, right? So in this picture, it's pretty easy to see, right? But in other pictures, sometimes they're going to have these triangles flipped upside down, and then they'll say that they might try to say like side AC is the side that's congruent to EF. Okay, but that would not be true because when we have this picture here, EF is going from angle to the angle that has two hash marks to the one that doesn't. And then A is going from the side that has one hash mark to the one that doesn't. So when you're looking for your non-included side, you need to make sure that both of the sides go from the correct angles. So whether it's the one that has one hash mark or two hash marks, okay, they both have to go from, let's say that, like in this case, they go from the two hash marks down to C, which is, we don't know if it's congruent or not, okay? E has to do the same thing. It has to go from the two all the way down to the one that we don't know anything about. So this is what you're looking for each one of these. All right. Let's talk about our conditions. Okay, here we need two angles. So we have, in this case, angle A is congruent to angle D. And then we have angle B is congruent to angle E. So those are our first two conditions, two angles that are congruent, two sets of angles that are congruent. For the side, we go from B to C. B to C has to be congruent to EF. And as long as we have these conditions, then triangle ABC is congruent to triangle DEF. All right, so let's go through these examples. Now we don't have any statements given to us. That's okay. I'll fill these in and we'll take a look at the reasons. So here's our given. Okay, we actually have two given statements. We have this first piece and then we have this second piece. And we know that they're both given statements because they're separated by this comma. So this first one, YZ bisects angle WYX. Okay, so that's our first given statement. Now let's go ahead and take a look at the meaning of this. YZ bisects angle WYX. So here's YZ. YZ bisects WYX. So what I'm going to do is I'm going to make these two in red congruent because of the definition of bisects. Okay. So since we wrote down this bisects, my next step, what I would put is that WYZ is congruent to XYZ. And the reason that I'm doing this first instead of writing this other given statement in box 2 is because I told y'all that anytime that you use one of your definitions, okay, so you write your given statement, the next step that follows is going to be whatever that definition is. So in this one, we have the definition of bisects. Okay, the other piece of given information is that angle YWZ is congruent to angle YXZ. So this is given to us. Now we just take that information and we put it on the picture. So YWZ is going to trace from Y to W and then Z. So that's going to be this blue angle. And then YXZ goes Y to X to Z. That's also going to be blue. These are congruent. And then the last piece, okay, line number 4. Notice that the two triangles share this side. They both share side YZ. So we can say that segment YZ is congruent to itself. And that's the reflexive property. So I'm going to give this one hash mark. Okay. Now we have angle, angle, side, angle, angle, side. So these two triangles are going to be congruent because of A, S. And to finish this off, we have to make sure that we write the angles in the correct order. So I'm going to start here with the one on the triangle that's on the left. So I'm going to go from W to Y to Z. Now with the other triangle, I have to start at the blue, go to the red, and then come down to the letter Z. So I start at the blue, I go to the red, so that's X to Y, and then Z. Okay, and there's our completed proof. Now number 5, okay, again in this one, okay, there's quite a few steps on this, okay, but most of it has to do with just the fact that we have two given statements and then a set of parallel lines. So we start with our first given statement, angle ABC is congruent to angle CED. So here's CED up here, and ABC is also going to be up here at the top. Oh, I'm sorry, we have 3 given statements actually. I didn't see that one that has the midpoint. All right, for the second given statement, we have AB is parallel to CE. Okay, and this is given. Okay, since this isn't a definition, we're going to leave it and move on to the next one. But before we do that, we're going to put our arrows on AB and CE. This will be important in just a few lines. So we have 2 arrows that show that those are parallel. Let me go back here and put that this is given real quickly. All right, for the third given statement, we have that C is the midpoint of AD. C is the midpoint of AD. So that's given. Here's AD. Okay, I'm going to do the whole thing in green. Here's AD. That's pretty bad. Let's try again. Here we go, AD. C is the midpoint, so here's C. That means that I have two congruent segments on both sides of C, okay? So when we write this out, okay, we end up with AC, because that is on the left side of C. So AC is going to be congruent to CD. Okay, AC is congruent to CD. And the reason that we do this, again, it's because of the definition of midpoint. The midpoint splits a segment into two equal pieces. Okay, so the midpoint C splits AD into two equal pieces. One's going to be on the left of C, and then one's going to be on the right of C. So our reason is the definition of midpoint. All right, now we're still missing two lines, okay? The last line is going to be what we're trying to prove. Okay, so I'm gonna go ahead and fill that in, and we just have to find one more piece of information before we're able to complete this proof. So what they want us to do is prove that ABC is congruent to triangle CED. Now, the only other information that we haven't used yet are these parallel lines, right? So with this, okay, with this picture, we're gonna have to use the parallel lines somehow to come up with a way to get another set of congruent angles, right? So we have these two angles that are in black that are congruent, okay? Now, there's no way for us to use angle side angle because this, the green segment, there's no way for the green segment to be an included side. So we're going to be looking in one of two places to come up with a set of congruent angles based on the parallel lines. Okay, so when I do this, okay, the parallel lines, the pink lines, have to make up some portion of the angle or some part of it. And when I do that, what we're doing is we're trying to find a line. Okay, there's only one line that makes, there has to be a line that both angles are going to share, right? So the pink arrows, whether I choose this guy or this guy, this pink only makes up this one. If I did this in brown, okay, this brown would only make up this D. So what I'm looking for is what line, if I chose this angle here and this angle, what other line makes it up? Okay, well, it's this green one down here at the bottom. Okay, so if I choose angle BAC here in brown and angle ECD in brown, okay, how can I say that these two are congruent? Like what would allow me to say that? Well, if we extend out, just theoretically speaking, this isn't the picture, and this isn't what they gave to us, but if we extend this out here, are these brown ones on the same side of this transversal or on opposite sides? Well, clearly the answer is that they're on the same side. Okay, so in terms of the parallel lines, there's only two sets of angles that have same side. It's either same side interior or it's corresponding. Now, right away, we know that same side interior, those are not congruent to each other. Those add up to 180. They're supplementary. So that only leaves corresponding left for us. So are both of these in the same position? Well, to figure out the same position, we come here and take a look at this pink line. Okay, if I extended the pink line out here and then here, what position is the brown in? Well, it's on the top and it's on the right for the triangle on the left. Over here on the right, this brown is on the top and it's on the right as well. I think I said left for this one. I meant to say right. So it's top right and top right. So they're both in the same position. What that allows me to do is to say that angle BAC is congruent to angle ECD. And the reason that I'm able to do that is because these are corresponding angles. And then that allows us to go angle, angle, side, angle, angle, side, AAS for both of these proofs. Okay, I know that explanation was a little bit lengthy, okay, but whenever they give you parallel lines like this, okay, you really have to think about what the picture would look like if the lines were extended on forever. Okay, so that's what I was trying to paint the picture here for. If this green line was extended forever and these pink lines were extended forever, how would this help us to solve the missing pieces that we needed to come up with for the last pair of congruent angles? All right, so that takes care of angle, angle, side. Next up, we have hypotenuse leg.